and this will look at an evaluation of the impact of project-based learning on student engagement in the Six Sigma Greenbelt Quality Module at Galway Mayo Institute of Technology, also in Ireland. And I hope that you're looking at a slightly sunnier day, Aurora, than I'm looking at out my window here in Limerick. Aurora is a lecturer in GMIT, Galway Mayo Institute of Technology, in the Mechanical and Industrial Engineering Department. Aurora worked in industry in the area of quality, project management and reliability. She also managed European projects in the LIFE, Erasmus and FP7 frameworks, and is an evaluator of European project proposals submitted in the framework of FP7, Horizon 2020 and Horizon Europe. Her areas of expertise include higher education, engineering, adult education, blended learning and project-based learning. And we're all looking forward to hearing more, Aurora. The floor is yours. Thank you.
Thank you, Anne. Thanks very much for the introduction. That saves me a bit of time. I'll go straight into my presentation of the study that I've carried out, which is called an evaluation of the impact of project-based learning on student engagement in one of the modules that I teach in third year for the mechanical engineering students, Six Sigma Green Belt Quality. This is actually this presentation is actually based on a master's in teaching and learning that I've completed recently. This is just a very short overview of my presentation, starting from the beginning, the aim of the study, a little bit of the context and literature review, going through the research methodology and the research findings, and concluding with some short conclusions and recommendations for further work. As the name of the presentation suggested, the aim of my study was to evaluate the impact of project-based learning methods on student engagement in this particular module. So that's exactly what I was looking at, the impact on engagement more than the details of the project-based learning and how it was applied. First, I will give you a little bit of the context. From our focus groups with industry and questionnaires, surveys that we carry out with industry every year, we base our content and our programs on. And this is what they want. They want our graduates to have hard skills and also soft skills. Soft skills were not always there, but as years passed, we've realized that that's what they want as well. So we put more focus on the soft skills as we reviewed our programs, our modules. However, what we've realized, not just me, other colleagues as well, is that sometimes some students don't engage with the engineering content. Sometimes it can be that it might be too difficult, too challenging. For example, in this particular module that I teach, it's the probabilities and the statistics, because it's pretty heavy on this side, on the maths. Sometimes it can be that students don't really find the soft skills so important. They don't think that that's so important in engineering. They just want just the technical part, to deal just with the technical part. So I've picked this module, the Six Sigma Green Belt module that I teach, first of all, because it's in third year, and second, because it's trying to equip students with both the hard skills and the soft skills. So it was a pretty good module for what I want to do. Then I had to pick a teaching strategy that would help with both delivering the skills, knowledge, competences that they need, but also to engage them with the content. So before I get into those details, I would first like to clarify what student engagement is. And I've adopted this definition from Dixon. Student engagement is the extent to which students actively engage by thinking, talking, and interacting with the content, their peers, and their lecturer. So that's the definition that I've adopted for my study as well. Also, I looked at different aspects of engagement, and I've identified in literature 3 aspects: behavioral engagement, which is the degree to which students are actively involved in learning activities; emotional engagement, which relates to the students' effective reactions to learning; and the cognitive engagement, which is the degree to which students spend mental effort to understand content. And you can see, hopefully on this slide, a few indicators that suggest these 3 types of engagements. For example, participation in class, communication in class for behavioral engagement, a sense of belonging to a learning community, learning satisfaction, for example, for emotional engagement, or in terms of cognitive engagement, self-regulated learning, degree of knowledge, perseverance, and so on. So this is what I've used in my tools for data collection to see if there are these any indicators of student engagement in these 3 areas. Then, as I said, I needed to decide on a teaching strategy that would engage students, but also help in equipping students with the knowledge and the competencies and skills that I wanted. And I picked project-based learning because it's a teaching strategy that's proven to enable students do all these things. I've come across loads of articles that showed project-based learning applied in different areas. I have to say that there weren't enough in the engineering area. So it's a good, I suppose my study is kind of contributing to that because there weren't enough in the engineering area, loads in the science area though. But as they are pretty much related, especially in this module that I'm teaching, it's enough to convince everybody that project-based learning is a good teaching methodology for science and engineering. Just to, in case you're not very familiar with project-based learning, I couldn't find a single definition that would look at all these characteristics of project-based learning that I've tried to show on this diagram. And that's why I've created this working definition for my study. Project-based learning, it's a teaching strategy that aims to achieve students' learning via participating in a project. First of all, which is very important, is designed to address a real world problem. That's a key thing, and I've used that in my module. And students work in small teams, the lecturer becoming a facilitator rather than a teacher in the traditional way. So basically, this definition is encompassing all these characteristics of project-based learning. So now that we are familiar with all the concepts that I've used, I can formulate the research question, which is: what impact has a project-based learning strategy on student engagement in the Six Sigma Green Belt Quality module? Just in case you're not familiar with Six Sigma, it is an improvement methodology which is very much used in industry, especially in the large companies, and we've loads of large companies, especially in the medical devices area around Galway, and quite a lot of our students end up working there. So eventually they will be exposed to Six Sigma. So it's a good module to get them familiar with the concepts and the tools before they actually start working in industry. Also, this module comes just before they go into work placement in year 3. I'd like now to present to you briefly the methodological framework for my research. So starting from my research question, I've situated my research into the interpretivism paradigm because I was looking at how students perceive the impact of project-based learning. Also coming from that is the case study, which is the methodology that I've used because it investigates a problem or a phenomenon, in my case, to get a deep understanding of it. So very appropriate for what I was trying to do. And I've picked for triangulation purposes 3 data collection methods: the observation, the questionnaire, and the interview. And each of the tool was carefully designed, reviewed with peers and with specialists in the area, and piloted with students. Very important for my research was ethics, especially because of my dual role as researcher and um, lecturer. This slide presents some data, some extracts from the quantitative data that I've collected. In this case, with the questionnaire. So the first chart here at the top shows indicators of behavioral engagement. For example, the highest bar here, the orange one, which shows that the students, quite a large number of students, listened to the explanations of the lecturer during the project class, or the purple and the brown bar show how students helped other students or received help from the other students during the project class. There were 22 respondents, so it's quite a large number of students that show different indicators of behavioral engagement. And the other chart here shows the responses to a question that would reflect cognitive engagement. So, for example, again, one of the highest bar, the green one, shows that the students understood what they knew and what they didn't know, or the brown bar here, again, quite a large number of students that shows that they preferred project-based learning to traditional teaching and learning because they could keep up to date with their work rather than leaving everything till the end of the semester when they would normally have final exams. Here are some extracts from the qualitative data that were collected both with the questionnaire and interviews. These ones are extracts from interviews. One with participant number 4 that suggests emotional engagement. It shows feelings of satisfaction and accomplishment at the end of the project. And this is an extract from the interview with participant number 2, which said that sharing ideas with the other students, with his peers, helped build their own skills. So suggesting cognitive engagement. The research findings were discussed along the thematic analysis, along the 3 areas of engagement: behavioral, emotional, and cognitive, that were identified in literature. So the sub-themes that appeared in each category: good participation of students in project class and enhanced communication with peers during the class dedicated to the project work. Something new that appeared, and it was due to the COVID-19 restrictions. At the time of data collection, we were all online, so everybody migrated to the online space due to the lockdown. So although from the interviews, from all the data collected, everything suggested a good collaboration and communication between students, they still perceived the online as a barrier to communication. In terms of impact of project-based learning on emotional engagement, students experienced feelings of learning satisfaction, of belonging to a small learning community, of help from the learning community. Also, they linked all those to the practical and of aspect of the project and the real life situation that they were given. So they were very happy with that. What I found from especially the quantitative data was that there were no feelings of enjoyment. And then I tried to clarify that with students during interviews and from the qualitative data from the questionnaire. And it turned out that the reason was, again, the online learning. They just felt that they couldn't enjoy college life in general. So these are third-year students. They've experienced already normal college life, going out with their friends, meeting their friends all the time. And then they were stuck in front of a computer. So they didn't feel the same enjoyment learning, of college life as they did before, and that impacted their feelings about the project work as well. In terms of cognitive engagement, it's transpired that the project helped students build their knowledge, especially again because of the practical work and the real life application. Also, the group work helped as well, and it seems that the project-based learning helps students understand better what they know, what they don't know, where the gaps are, and also helps in terms of self-regulated learning, which is really important for engineering because technology evolves so fast that they really need to be lifelong learners. So it looks like project-based learning helps that. So I could conclude that project-based learning has a positive influence on all the three categories of engagement: behavioral, emotional, and cognitive, at least in this particular module that I'm teaching, Six Sigma. The contribution to knowledge, I would consider the fact that I looked at all the three aspects of engagement, behavioral, emotional, and cognitive, whilst other studies looked maybe only at behavioral and emotional, or others looked particularly at the cognitive aspect. And of course, there is a very useful contribution for my module, for our department, for the engineering discipline. And I'd say the most important contribution was the opportunity to hear the student voice, because everybody knows that different teaching strategies can be successful, are good, and we think that they are good, but it's very important to see what students actually feel, how they perceive all these, and that this study gave me a good opportunity to understand that and to use it for next year when I'm going to refine my teaching strategy for this module and for the other modules as well. Of course, there are limitations to the study. Thank you. The number of respondents was 22 out of the 37 students that took this module, which was an elective module. So more case studies based on the same methodology that I've presented here, but maybe including different disciplines, engineering or not, different degree levels and different years of study would help to enhance our understanding of how project-based learning impacts the student engagement. Also, I looked strictly at student engagement, the three aspects that I've mentioned, but I didn't look at the correlation between engagement and academic performance. Now, I have to say that looking at the student results, there wasn't a big difference between this year and other years. I've only started teaching this module, I think, 3 years ago, so it's been 3 years of me teaching this module. But it would be interesting to see if the student engagement has anything to say in terms of academic performance. This is just a short list of references that I've used in my for my presentation, and that's it from me. Thank you very much, and if you have any questions, I would be very happy to answer them.
Thank you very much, Aurora. That was really interesting. Again, such a diverse kind of a spread in this session, which has been really wonderful. Actually, I have a question for you. Just looking through the chat, I don't see anyone else from the floor yet, so I'll get in there quickly. We see problem-based learning getting a lot of traction for good reason at university, and it can work quite well. And you used it with your third year group, and I know that some of my own research looks at what's happening at second level here in Ireland, and I can see PBL kind of creeping in a little bit at second level. But I wonder, you know, at what stage what age group or at what stage of education would you see being an appropriate stage to introduce PBL?
To be honest, at any age. For example, my daughter is sometimes working on some group project for schools, and she's in 5th class, but they did that since I think 3rd class. So I'd say even earlier, it's fine because it helps them work together. Even kids might have different personalities, so working in a group helps to polish a little bit, if you want, know what I
Yeah.
mean, and to get certain skills and certain competencies in that area. Because although, especially in these days when technology has evolved so much, and we are talking about industry 4.0, quality 4.0, and so on, so loads of automation and everything, soft skills become more and more important, and project skills can help that a lot. So as
Mm.
early as possible, I'd say it would help. Of course, projects that would be appropriate to the age, uh, but I'm pretty sure that it would work very early in school, in primary
Okay.
school even.
And just one other question. I know that sometimes my experience when I've had to assess group work is that sometimes there are passengers within the groups. So one student will decide to participate or to engage less. Has that been an issue, and what have you had to do maybe to overcome it?
What I've done, my teams were very small, only 2 students.
Okay.
And especially because everything was online, so it would have been much more difficult for a larger group, I think, to collaborate. So my teams were very small, and there was only one case when the 2 students didn't really work well. But apart from that, I've also done observations. So during a particular class that I've allocated to project work, I observed students in breakout rooms.
Okay.
So I could see that they work well together.
Yeah.
Even sometimes when they were silent, I could hear them typing, or um, uh, they were asking questions when needed, and so on. So I could see that they work together quite well, apart from one
Well,
one
that's
group.
really interesting. It's really good to hear that real life experience of it, because often when we read the research or you read the case studies, that often doesn't get reported, or we don't see the dirty details. So it's
Yeah.
really good to get to see behind the scenes. Thank you very much. I see some comments there in the chat. Great to learn more about engagement, an important topic, and other people found it very interesting. So thank you. I see someone has a question. Do you want to put it into the chat? It's Jaro Sivits.
Yes, my name is Beata Jarosevich from Hungary, from Budapest. I would like to ask you a question. Did you have a control group, or you chose the project method only with one group from university?
No, I didn't have a control group, and that's one of other things that I would like to do. It's a bit difficult because I think what I would try to do next would be to use the same group in 2 circumstances: traditional teaching and project-based learning, because I'm not sure it would work if it's not the same group. I'm not sure the results would be reliable if I don't. But no, I didn't use it this time, and that's for the plan for the future.
This is a very good point. I ask you because I try to use at university, but at university it does not work because students, they do not attend the classes, and that's a big problem in our country. Maybe you are much more luckier and you can have more students engaged in the courses. And do you have a concrete project example to look at to the mathematics or statistic, the subject that you are teaching to be solved out with a project method? Do you plan something like that for the future?
Yeah, so well, first of all, I want to say that the way this module is taught, it's like a lab. So we have 2 hours per week with small groups, 20 students. So that's why it works. It's not like 100 students in a lecture theater. It's small groups, and it worked quite okay, both online and, well, they weren't very happy, as I said, online, but still it worked. So I didn't have any issues in terms of what you're saying, attendance. In terms of project, what I will do, I have prepared for next year a project, just because these students are not in industry. It's a bit hard, so I need to give them something to simulate. So what I'm giving them next year is to slide a coin to reach a particular distance, and that would be their process, if you want, and they will have to improve that process. So they will have to collect data, they will have to analyze the data to present data, they will have to analyze the data to spot any issues. So to use, I will ask them to, just as I've done this year, but this time it was 3 separate projects, smaller projects, but I will give them a full project, which is going through all the steps of the Dimache methodology, the Six Sigma methodology. So define, measure, analyze, improve, and control. So they could come up with some technical solutions as well during the improvement. So hopefully it will work well.
Thank you so much. I was very happy to hear about, because I'm also involved in project method research and making physics, and maybe collaboration we can talk after later on.
Absolutely, I'll put my email address on the chat box there, because I think I forgot to put it on the slide there. So you have it in in the chat box there. If you're interested, I would be very happy to discuss anything and to exchange.
Okay, thank you so much.
Perfect. Thank you so much.
That's super. Excuse me. Thank you very much. Can I ask of the presenters that we had in the session this morning, if you wouldn't mind turning on your cameras for a moment, if you're still in the room? I want to take a quick photo of the group. Thank you, Roberta.